Okay, welcome to this video, and this is going to be our last video on related rates of change and on differentiation in calculus. Then we're going to go on to integration. So this is the exact sort of question you're going to find in your Leaving Cert. It's going to follow the same method and the same way of finding out basically what you're trying to find out. Okay, so obviously it might not be a cone, but just pay attention to the little steps in this, and then you can apply them to any question. So the problem is that someone's designing a cone to catch water that's leaking from a tap. Okay, the tap is leaking at a rate of 0.1 centimeter cubed per second, so that's how much water is coming out, and obviously they have an upturned hollow cone like this. Yeah. So the first question, write the volume of water in terms of R and H. So I'm going to just read out the questions as I do them. So we're going to do part A first, and again I've rubbed out 1, 2, 3, and 4, the steps I normally have up here, just to make extra space, but we're still going to use those steps. Okay, so write the volume of water in terms of R and H. So you can see the water here is going to make a cone shape as well. So the volume of water is the same as the volume of a cone. So V is going to be equal to 1 over 3 pi or squared H. Okay, and that's just from the formula book. We have to write that down. So next question, I'll go question B. Using similar triangles, find a relationship between R and H. So this is the kind of question they're going to ask you. You're going to have to find a relationship. It might not always be this one with similar triangles, but this one and also part C is about finding it in terms of one variable. And yeah, you'll see what I mean when you start doing a few questions yourself. You can't differentiate this because there's an R and a H, so you need to get rid of one of the variables. So I'll go ahead anyway and do this. So if you look at this cone here, just look at it as a triangle like this, so follow the pen. I'm going to draw this triangle in a second to so you get where I'm getting this triangle from. So if we draw this triangle out there, that's inside the cone, we have R here, we have 1, we have H there, and then we have 10 up here. Yeah, so if you remember back from junior cert, you can say these are similar triangles because they have the same angle here and the same angle there. Okay, I'm going to scribble this in. So you don't have to prove this, I was going to show this to you. So basically that these two triangles are going to be in the same ratio. So if you write R over H, so the bottom one over that one there, that's the same as the ratio for this bigger triangle here. So that's going to be equal to 1 over 10. Okay, so it looks like a 1D, but 10 is what I'm looking for. Yeah, so it says express similar triangles, find a relationship between R and H, and that's what we've done here using similar triangles. Okay, so to even give you a hint there, that would be quite difficult to spot otherwise, but hopefully that makes sense now. We're going to use this later on in the question. So I'll go to red, and we're going to do part C. This is express the volume in terms of H. So this is what I mean. We know that V is equal to 1 over 3 pi R squared H, okay? But this isn't much good to us because we don't know R, we don't know H, and we can't differentiate it. So what we're going to say is we're going to say here, I'm going to say that R is equal to H over 10. So I got this from up here, I just multiplied both sides by 10, or sorry, by H, and we get R is equal to H over 10. So I'm going to sub this into this formula here. We're going to get V is equal to 1 over 3 pi H over 10. Remember, R is equal to H over 10, so we're just subbing H over 10 into R, squared multiplied by H. So that's going to give us 1 over 3 pi H cubed over 100, which altogether is going to give us 1 over 300 pi H cubed. Okay, so that's our new term, our new equation for volume just in terms of H. There's no R, and now we can differentiate it. So that's the most useful thing, and it's generally, you're gonna have to do this in almost every calculus question you do. You're gonna have to get rid of one of the variables. We got rid of R and put it just in terms of one variable. Okay, I'll go in big dark blue and we'll try question D. Write the rate 0.1 centimeter cubed per second as a differential. Okay, I'll go ahead and do this. So what that means basically is, sorry, I'm going to scroll back up. So this rate here, the tap is leaking at a rate of 0.1 centimeter cubed per second. Write that as a differential. So that just means write it in terms of d and d, so like a dy dx term. So what we're going to write is, that's actually, sorry, I keep scrolling back and up. But if you look at that here, centimeter cubed, that's volume, and then that's per second, and that's time. So that kind of gives us a hint there. It's going to be dv dt. Okay, because it's the rate at which, so the tap is leaking at 0.1 centimeter cubed per second, that means that the volume in the cone, because remember it's going to leak into the, I draw little dots here, it's going to leak into the cone, yeah? And the volume that the cone is increasing at is 0.1 centimeter cubed per second. So it's, again, the rate of change of volume, so dV dt. Okay, hopefully that made sense. And we'll go green for the last one. Give me 1 second. Sorry, I'm just going to write one more thing in here. That's equal to, 0.1 centimeter cubed per second. Okay, so now question E, so I'm going to scroll back up, is going to ask us, find the rate at which the water is rising up the cone when the cone is half full. Okay, so this is kind of a hard one, but we'll manage it anyway. Okay, so find the rate at which the water is rising up the cone. So what's that? That's what we're looking for. So if we think back to the 4 steps we did for the other questions, there's always 4 steps. The first one is right what they're looking for. So the rate at which the water is rising, that's H. So the water is rising at H. So the volume will be getting bigger at a certain rate, but we only really care about how fast the water is getting taller, because once it gets to a certain height, it's going to spill over. We don't want that. Don't really care about how much volume is in it, just the height. So find the rate at which the water is rising up the cone. That's going to be our first one. So we're going to write these steps out. I'm going to say, let me go change to green. Just ignore that. 1 is what we're looking for, is dH dt. That's the rate at which the water is rising. Okay? Then number 2, I'll go back to orange. What we're given is we're given dV dt. So these steps I'm writing, 1 and 2, they're from the last 2 videos. Number 3 is now we have to link these. So I'm going to write dH dt is equal to dV dt multiplied by, and we have to write something here that when you multiply it by this, you're going to get dH dt. So we know we're going to have a dH on the top, yeah, because there's a dH on the top here and there's no dH on the top here, so it's going to have to be, I'll change color for it actually, I'll go yellow. This is going to have to be a dH, and on the bottom, it's going to have to cancel with whatever's on the top over here, so it's going to be dV, okay? So our next step then is to find dH dV. Okay, that's the last step, and then we can solve this question. So let me just draw a line down there. So dH dV, how are we going to go about getting that? The answer is, first we're going to get, see if we have here V is equal to 1 over 300 pi h cubed. Okay, I'm going to write that down. I'm going to say V is equal to 1 over 300 pi h cubed. That means we can get dV dH. Now I know this isn't what we're looking for, but we can find dH dV once we know this. dV dH is going to be equal to 3 multiplied by 1 over 300 by pi h squared, which is equal to, actually no, I'll leave those. I'm going to drop a line again. And again, dV dH then will give us pi h squared over 100. So the 3 is going to cancel with the 300, 100 squared, etc. Yeah? Okay, we have dV dH, but we want dH dV. So if you remember back to the first video we talked about related rates of change, there is a way we can relate these. We know that 1 over dV dH is equal to dH dV. So that means dH dV is going to be equal to 1 over pi h squared over 100, and that's equal to 100 over pi h squared. So it's ever 1 over a fraction, you can just flip the fraction like this. It's kind of a little trick, okay? So 100 over pi h squared. So now we can fill in this here. So again, I'm going to draw one more line, and hopefully I'll be able to squeeze everything in. I'll go back to red. So dH dt is going to be equal to dH dV by dV dt. So dH dt, dH dV is going to be this thing here, 100 over pi h squared. 100 over pi h squared times dV dt, which is one here is 0.1. Okay, this is going to be 100 over pi and h. So I'm going to scroll back up now. It says find the rate at which the water is rising up the cone when the cone is half full. So if the cone is half full, that means that h is going to be at 5 centimeters. It's going to be halfway up. Yeah. So I'm going to scroll back down. We're going to stick 5 in there. 5 squared by 0.1. And I'm going to stick that onto a calculator. Write it down in purple. And then we're going to have dh dt, which is our final answer, is going to be equal to, give me a second. 1 second. So sorry, if we stick that onto the calculator, we're going to get our final answer is 0.127 centimeters per second. So sorry for that, that was quite a long video there, but hopefully that showed you, and like this is exactly the kind of question you're going to get in your Leaving Cert. There's going to be a couple of different things, and they're going to help you, so make sure you work these out, and they're going to help you solve the final thing, which is ultimately what the question is asking. But they're nice because they kind of tell you a few different things, they make you work out a few different things to start to build you into it. So I'll just leave it there because I don't want to make the video any longer. It's already 11 minutes, but I hope that all made sense, and hope calculus all makes sense. We're going to move on to integration next.